Welcome to today's webinar, and good afternoon, good morning, wherever you are. My name is Jan Rosenau, and I'm the European Director of the Regulatory Assistance Project. And today's webinar will be all about the integration of electric vehicles. As you all know, it's increasing quickly all over the world, and the benefits of electric vehicles in terms of carbon reduction, local air quality improvements are very well recognized now. But electric vehicles also have significant benefits for the power system. And in order to fully exploit those benefits, we need the right policy and regulatory framework to be in place. And in this webinar, we will explore how smart pricing, smart technology, and smart infrastructure in particular are the three key ingredients to integrate electric vehicles most beneficially into the power system. Before we start, just a few housekeeping issues. You can submit your questions through the questions pane on the webinar control panel to the right. And please also note that we are recording the webinar, and we will send out links to the recording as well as the PowerPoint presentation to anybody who registered for the webinar. Let me now introduce today's speakers. So Julia Hildermeier is our transportation expert at the Regulatory Assistance Project with almost a decade of experience in transportation issues. Before coming to RAP in 2018, Julia worked for the European Federation for Transport and Environment, and she has done her PhD many years ago on e-mobility policy. Christos Kolokathis is coordinating RAP's power markets work in Europe, and he has a background in power sector regulation, having previously worked for the UK regulator Ofgem. And Christos has degrees in electrical engineering and energy systems. I will now hand over the presentation to Julia and Christos. And please enter any questions that you might have in the questions pane anytime, and we will pick up those later on. So over to you, Christos and Julia.
Thanks, Jan, and welcome everyone. Today's webinar will follow three parts. By ways of introduction, we'll first discuss the opportunity of shifting to e-mobility and the benefits of integrating EVs into the grid. We'll then discuss promising practices of EV grid integration mostly around Europe, as we've analyzed in our study that this webinar is based on. And lastly, we'll conclude with some policy recommendations. Now, what is the opportunity of EV grid integration, and why is it so important that we get it right? EVs fundamentally help to reduce emissions in several ways. First, they are more energy efficient. They use about 1/3 of the energy of a comparable combustion vehicle. From a transport perspective, locally, they're needed urgently in cities to reduce air pollution. And here, of course, they're only one ingredient of a larger shift towards a cleaner and more efficient transport system. But globally, they're of course needed to reduce CO2. As a reminder, the European transport sector is the only sector in which CO2 emissions are actually still growing. And this graph from the IEA's 2019 EV Outlook, just published, shows that the EV fleet we can expect by 2030 will avoid about 220 megatons of CO2 equivalent, compared to a fleet made of combustion vehicles, which would have almost doubled these emissions. And this scenario is modeled on today's announced policies. So with more policy support, we're likely to see more environmental benefits. Let me reiterate that, as does this scenario, when we speak of electric vehicles, we mean all vehicle segments, from passenger cars to buses, although we've mostly focused on passenger cars in our analysis. And the carbon reductions EVs deliver are higher if more zero carbon electricity is used to drive them. And because EVs can decarbonize transport and use cleaner electricity, they present a great opportunity for the power system itself to decarbonize. And this is what we're going to focus on today. So what are these grid benefits that we're talking about? EV charging can be shifted to hours when it's better for the grid, and we'll explain what exactly that means further on. And this flexibility makes EVs an enormous resource for the power grid. It can be used to help integrate increasing volumes of variable renewable energy resources. And EV's flexibility also helps system operators to manage the grid. Doing so, they can reduce system costs. So less cost has to be shared among all electricity users, and that lowers our electricity bills. So here is where EV grid integration creates benefits to all electricity users, and not just EV drivers. And to make sure we reap the benefits, charging EVs smartly is key. So what do we mean by smart charging? We mean shifting charging to times when costs for electricity are lower, without compromising the vehicle owner's needs. In other words, optimizing charging from a grid and transport point of view. Note that in this study, in this webinar, we're not looking into discharging from EVs into the grid, also known as vehicle-to-grid services. Because until V2G becomes commercial, there's a lot we can already gain with smart charging, and we want to highlight that potential in this webinar. So why is smart charging so important? At present, most electricity consumers have flat electricity tariffs that do not give them incentives to charge at specific times. And what happens with unmanaged charging is illustrated by this graph. The curve you see depicts the load curve in a big distribution area in Germany on a recent peak day. It shows a clear morning and evening peak. And this evening peak would increase if all EV users plugged in their EV when coming home. And that you can see in the red curve. And first evidence from Europe's most mature EV market in Norway shows that that is exactly what happens if we don't set incentives to shift consumers' charging to other hours. And instead, we want to see shifting charging to hours when it's better for the grid, as you can see by the green curve, for example, to night hours when electricity is cheaper and most likely cleaner. And why that inherent flexibility of EVs we've just discussed helps to integrate renewables, Christos will explain in more detail.
Thanks, Julia, and welcome to everyone. So, as Julia already mentioned, EVs have a lot of inherent flexibility. A modern EV takes about 3 to 4 hours to fully charge on a 7 kilowatt charger, while under the private ownership paradigm, it's parked for around 95% of the time. This means that it's parked for 21 to 22 hours per day. What one can do is basically, since this only requires a fraction of time to fully charge, is to shift this charging at times when there is a lot of renewable energy electricity in the system. So for example, during noon and afternoon hours when there is a lot of solar generation in the system, or during night hours when there is a lot of wind generation, instead of the 30 hours during the day. In this way, one can cost-effectively integrate renewables in the system. In addition to this, EVs can provide a lot of flexibility for system operators. This graph comes from California, and it shows the famous Californian TAG curve. Basically, since distributed generation deployment has increased on the Californian grid, the net load, that is the load seen by the transmission system operators, so the load at the transmission network level, is dipping significantly during the noon and early afternoon hours. As the sun is setting, the net load increases very rapidly, and this is one of the key challenges that system operators are already facing and will be facing more in the future. Now, what one can do to resolve this issue, to address this challenge, is to shift charging during the middle of the day when there is a lot of solar generation in the system. And in this way, the net load curve increases, and as a result, the ramping requirements when the sun is setting decrease. System operators have to procure less reserves to follow the net load curve, and as a result of that, the total system costs decrease, while also charging EVs with clean, cheap, renewable electricity. And we'll now move back to Julia to explain how we can realize these benefits.
So after this introduction on benefits, let's dive into the core of our talk today. We've identified 3 key ingredients to make EV integration most cost-effective and beneficial. First, smart or more cost-reflective pricing to encourage charging when it's better for the grid. Second, smart technology to make it easier for consumers to reap these benefits of smart pricing. And third, smart infrastructure. That means infrastructure located in a grid-friendly way. And we'll explain what each of these mean in more detail, starting with smart pricing.
Thanks, Julia. So what we basically mean by smart pricing is time-varying electricity prices that better reflect the cost for producing and delivering electricity to the final consumer. And through this type of pricing, one can direct charging to lower cost hours for the grid. In this way, an EV owner can save on their bills, while at the same time, the total cost for the system decreases, thus offering wider benefits to all electricity users. As an example of this, by shifting charging during the night hours when networks are largely underutilized, one can avoid unnecessary investments in new grids while at the same time making better use of existing assets. And before diving into specific examples, just a reminder of the electricity bill. So this pie chart shows the electricity bill for the average European household as of 2015. This has barely changed in the last few years. And the energy costs, so the cost for producing electricity, are about a third of the total bill. The network costs, the yellow bar in this chart, so the cost for delivering electricity to the final consumer, are just over a quarter of the bill. The rest is for levies and taxes. For today's webinar, we focus on the energy and network components of the bill. And the first example that we're going to show is the simplest type of time of use tariff. Specifically, this example comes from Spain and a utility called Iberdrola that is offering an EV dedicated tariff. The tariff is split in a day and night charge, and the night charge in particular, the blue bar on this graph, is about a sixth of the day charge. This sends a very strong incentive to EV owners to charge during the 6-hour window when this price is applicable. As an example, an EV owner that does around 10,000 kilometers per year can save around 80% on their costs, on their energy costs, compared to a driver that is on the standard flat rate of the company that pays 14 eurocents per kilowatt hour as depicted by the dashed line on this graph. And time of use tariffs can already offer significant benefits for integrating EVs cost effectively into the grid. Now, as we move towards a power system that is more dominated by variable renewables, more dynamic tariffs that change more often according to the actual conditions on the grid, can offer even greater benefits. This next example comes from Great Britain and a supplier called Octopus that is offering the agile tariff for a few years now. The agile tariff is linked to the wholesale prices at the day ahead stage, and the supplier communicates the applicable retail prices to consumers for the day ahead at 4 p.m. of every day. In this way, consumers have time to adapt their charging behavior. And what this graph shows in more specifically is the charging behavior of EV owners prior to signing up to the agile tariff, the red line, and after, the green line. And basically what it shows is that EV owners on the tariff have shifted their charging during the night hours from the evening peak hours. The supplier estimates that a consumer on this tariff saves on average about 150 euros per year compared to their customers that are on the flat standard tariff. Now, the previous two examples focused on the energy component of the bill. And while the energy component of the bill sends signals about the cost for generating electricity, it doesn't send any signals about the actual use of the network. And as we saw earlier, network costs are about 1/4 of the total bill. That's a quite important part of it. For this reason, it's also important that network tariffs send appropriate signals to consumers and that they are time varying as well. This example comes from Denmark and specifically from a distributed system operator called Radius that serves 1 million consumers in Copenhagen and the surrounding area. Radius has introduced time of use tariffs recently for consumers that are connected to the low voltage and medium voltage networks and that have a smart meter in place. The example on this graph is for households in particular. And basically Radius has split the entire year in two seasons, the summer and winter season, whereby the winter season is from October to March. And for the winter season in particular is applying a peak charge, which is about 3 times as high as the off-peak charge. This is applicable for 3 hours per day when the DSO is facing the highest demand in its service area. And what Radius is aiming at is shifting consumption away from these hours. And by this, they can contain or eliminate entirely network reinforcements that are quite expensive. We just looked at examples for smart pricing. We'll now move to the second element that we have identified, smart technology and how it can maximize the benefits of smart pricing. And first, what do we mean by smart pricing? In its simplest form, smart technology includes any technology that can monitor real-time or close to real-time consumption and can communicate this information to the final consumer. The consumer or a third party can take this information and adapt their consumption. In a more advanced form, smart technology includes any automated controls that can optimize one's consumption based on a set of signals like prices or carbon emissions, without needing their intervention. Now, this next graph shows peak demand reductions achieved for a number of pilot projects of smart pricing from across the world, without and with smart technology. And there are two conclusions that one can draw from it. The first one is that consumers do respond to prices, as it can be seen from the different levels of peak demand reductions that have been achieved throughout the pilots. And the second conclusion is that smart prices deliver maximum benefits when they are complemented with smart technology. And this also works the other way around. And now a short example on automated optimized charging, which comes from the Netherlands, and more specifically from a startup called Jetlix. Jetlix offers smart technology complemented by an application, and basically the driver provides information into the company's application, like it can be seen on this photo, about their needs. So what time do they need to set off from home and how many kilometers they need to do. Based on this information and other signals like prices and the availability of sustainable electricity on the grid, the technology assesses when it's best for the driver to charge their car and can automate this. All in all, this technology can lower the consumer's bill while at the same time charging with sustainable energy. And with this, I'll hand back to Julia to talk us through the third element we have identified. Sorry, first we have Jan to see if there are any clarifying questions. Over to you, Jan.
Thank you, Christos. So far, there are no clarification questions, so I suggest we just continue and take any questions after you finish the presentation. So back to you.
Okay, great. So far we've discussed how smart pricing and technology can accelerate beneficial EV grid integration. Now let's turn to the third area of today's webinar, smart infrastructure. And by that, we mean smart siting of infrastructure that makes it grid friendly, but also, of course, cost effective. And that requires actually tailored solutions, because as the EV market grows, more and more different use cases emerge. These can range from electric taxi fleets needing fast charging to electric delivery vans for city logistics, but also cover private EVs without off-street parking. So questions to consider for governments and planners are, what is the best location to meet mobility demand? But at the same time, what is the best location to use existing grid or street infrastructure to reduce costs? And likewise, which kind of charging infrastructure is needed to allow optimized charging? Do I need to optimize by time or by location? So let's look at a few promising practices. The most obvious use case for smart charging are workplaces and multi-unit dwellings, where most of tomorrow's charging is likely to take place. And these are very suitable to integrate EVs beneficially for several reasons. They offer an existing electricity network because they're often located in dense areas. The cars are parked for long office hours or overnight, providing flexibility to optimize timing of charging during off-peak hours. This can help to absorb renewables, for example, strong wind power during the night or solar generation during midday, as we've discussed earlier. And of course, this type of smart charging behavior can be and should be encouraged with time-varying tariffs. And as far as charging in public spaces is concerned, a good planning practice for cities is to use existing infrastructure. And by that, I mean grid and street infrastructure to reduce cost. An interesting example can be found in London, and you can see it on this slide. The city appointed an infrastructure supplier to convert public light poles into 3 to 5 kilowatt charging points for normal charging and parking over longer time periods. And one of the reasons to opt for this solution was simply the lack of space on the sidewalk, and of course, the cost reduction it offered. The cost per charging point, according to the supplier, could be reduced by several £1,000s per unit. And there are additional efficiency benefits to make with these solutions. One district in London replaced the traditional inefficient light pole bulbs with an LED light, so they could use the excess power to charge the EV's battery. So planning is essential for smart infrastructure siting. And this example that you can see on this slide shows that it also should be demand-based. The city you see is Amsterdam, where the municipality builds EV charging infrastructure upon citizens' request, according to certain criteria, such as minimum distance between the charging points. And the city also involves grid operators to place the charging point to ensure optimal location. And this practice helps to address siting uncertainties. It helps the city to have to coherently plan infrastructure, to have an overview of where the charging points are placed. And it creates knowledge and transparency to optimize future rollout of infrastructure. And that's important. In fact, the Dutch EV charging infrastructure rollout has been documented since its early days by a research institute who created one of today's largest publicly available data sources on EV charging behavior. But what other options do planners actually have when seeking best location for infrastructure? The last example in this section is just to illustrate that in some specific cases, for example, when using existing capacity is too expensive, infrastructure may be needed that is not constantly connected to the grid and independent of peak times. And that is where battery-based or battery-assisted high-power chargers can be used. And of course, the very sharp decline in the cost of batteries makes this combination very attractive. What you can see on this slide is a ferry by Havyard in Norway, who just went to production with a series of purpose-designed battery electric ferries. And there are more and more electric ferries in coastal regions, and some of these use battery-based charging systems. For example, an electric ferry operating between two sides of a fjord charges fastly from 2 battery buffers at each quay when it is ashore for about 10 minutes. And these port batteries charge from the grid in slower mode while the ferry is away, thus avoiding to overload the grid. And battery-assisted fast charging is also experimented in automotive applications, and that includes using second life car batteries to assist fast chargers, and even moving battery-assisted fast chargers around to locations within a city, for example, where there's most demand for fast charging. And you'll find more examples of this type in our paper. But let's now get to our final part of today's webinar, our policy recommendations.
So our policy recommendations are for policymakers in Europe, and they also use as a starting point existing European legislation. We're not going to describe in detail this European legislation, but we are more than happy to take any questions during the Q&A session of the webinar. So in terms of smart pricing, we believe that the most important aspect is to firstly prioritize the implementation of the clean energy for all packets. And there are two key elements that I would like to highlight on this. The first one is establishing well-functioning and faster wholesale markets that can reveal the true value of flexibility to the system. And the second one is the further development of competitive and open retail markets where all different kinds of players can participate, and then consumers are in the very center. In terms of the energy component, we feel that competitive, open, and free retail markets can deliver the smart pricing designs that will help to integrate EVs at least cost. But there are also a couple of cases where regulators might need to intervene and set EV tariffs. The first case is where the market itself does not deliver, for example, because of lack of effective competition. And the second case is where regulated prices is the norm in the market. When it comes to the network component of the bill, we recommend that policymakers, that NRAs, regulators, require from network companies to establish time-varying tariffs. In any case, it's very important that regulators and network companies monitor the effectiveness of the tariffs. This is going to be a long trip, and it's important to understand along the way what is and what is not working for consumers. When thinking about smart technology, we recommend that there is a requirement for smart functionality in any type of electric charging solutions. So what that means is that whether the smartness is in the car, the cable, or the charging point itself, that it should enable the application of smart retail prices. As we saw earlier, the coupling of smart technology with smart prices will deliver the maximum benefits for the system. In addition to that, national legislation can define technical requirements to drive the kind of technology that we want to see in the market. As an example of that, Great Britain has recently passed a legislation called the Automated and Electric Vehicles Act of 2018 that effectively allows policymakers to set minimum technical standards for any new charging points that are being deployed. And with this, I'll pass back to Julia.
And as far as charging infrastructure is concerned, several opportunities exist for policymakers as well. European member states have the opportunity to better and quicker equip shared parking spaces in buildings, company or multi-unit dwellings, buildings, by going beyond the minimum requirements of the recently revised European legal framework for this. That's the so-called Energy Performance of Buildings Directive. But they can also do more to accelerate the rollout of public charging infrastructure by implementing current legislation more ambitiously. The regulations underlying public charging, the so-called Alternative Fuels Infrastructure Directive, are likely to be revised in the coming years on EU level. And that is also a great opportunity to set more ambitious and differentiated target requirements for future infrastructure, taking into account the increasingly different use cases that I mentioned earlier. Different vehicle segments, geographical location of charging points, whether I am in the urban or rural area, and so on. So more generally, integrated planning, taking into account transport and grid needs, is key for governments, but also in particular for cities, to roll out smart and grid-friendly infrastructure. And that includes to anticipate future use cases such as smart charging and grid integration of electric delivery vans and electric trucks. And an effective way to do that is to run pilots. Last but not least, in all of these cases, smart infrastructure planning requires to explore how renewables can be integrated in charging these EVs. And for details on all of these recommendations, I refer you again to our paper. And with that, we're at the end of our presentation, and I head back to Jan to see if there are any questions.
Thank you, Julia. A lot of questions coming in. And the first question that I would like to ask you is, what are the barriers to actually implement the strategy that you've outlined in the presentation? And who will be in charge of actually driving this and making that happen? And I think Julia and Christos, you can probably both share the answer to that question.
Thanks, Jan, and that's a great question. It's quite broad, so I think we'll try to give a few pointers about what needs to change and who needs to take actions forwards. And so touching on the different elements that we presented today, we can start from wholesale markets. And one of the key problems with wholesale markets is that there are many distortions in them. They're not operating, they're not functioning as they should. So the first ask would be for regulators to establish well-functioning markets. One concrete action would be to remove overcapacity from the market, for example, that tends to dampen energy prices. And this could help to reveal the true value of flexibility in the market. In addition to this, on the retail side, I mean, in many member states that have a long history of liberalized markets, that they've opened their markets for a long time, you can actually see a lot of the kind of smart pricing that we presented today. I'm thinking, for example, Scandinavia, Great Britain, the Netherlands, that have liberalized the retail market for quite some time now. You can see dynamic tariffs becoming more and more common. So as we said also in the webinar, this should be the goal, to create this type of competitive, liberalized retail markets. Where this isn't the case, regulators can again implement, incentivize, let's say, the market to bring about this kind of tariffs. And where regulated prices is the norm, then it would be prudent for regulators to set EV-dedicated tariffs. On the network side of things, I mean, this is probably an area that more work is required. Unfortunately, we are seeing a trend towards more fixed type of network charges that don't send any signals to EV drivers whatsoever, to charge during the best times for the grid. And this is an area where we believe that regulators should be looking more thoroughly to put appropriate designs in place. Finally, on the technology side, I mean, when it comes to the customer side of things, I think there are really a lot of very good examples of things moving forwards. We are already seeing technologies that enable automated controls. Automated controls are great because they reduce the risk for consumers of not using very well at smart prices. And at the same time, they take away any hassle from them to have to intervene. Where we see more of a role, let's say, for policymakers to take action is in establishing technical requirements, in establishing the deployment of technologies that will enable the application of smart prices. And I think I'm done for now. I will hand over to Julia to chip in this question.
Yes, thanks, Christos. You asked about barriers, and I just want to re-emphasize that available and accessible charging infrastructure for EVs is also one of the biggest barriers for EV uptake in Europe. And we really need more incentives for companies to equip workplaces, for property managers to equip shared parking places in buildings. And options exist and are known. For example, France and Spain have done similarly as in California and promote and implement owners and tenants' right to charge. So they can ask for a charging point to be installed where they need it. And states, of course, can also grant incentive programs for property owners to develop this. And this is similarly done in California, in particular when refurbishing buildings or equipping new buildings. So rollout of smart infrastructure, smart charging as a consequence of this is of course likely to happen in markets where this grid integration and integrated planning is happening. So to answer the part of the question, where is it likely to happen? I don't want to give you a list of concrete countries, but if you look at places at advanced markets in Europe, such as Netherlands, I think these are places where we're likely to see grid integration and smart charging likely to happen soon.
Thank you, Julia, and thank you, Christos. The next question is actually nicely linked to the first one and your response. And that question is, what about any projects that involve public transportation systems and companies? So I think this is a question, Julia, that you could probably answer easily, and over to you.
That is indeed a good question. And first of all, I hope we've made clear that electric, when you talk about EVs, we talk about all kinds of vehicles, and that includes, of course, electric buses that are part of public transport. And electric buses are a market that is growing rapidly because cities need to fight urgently air pollution. That is a big problem. Electric buses need to be integrated in an electric system, and for this you can choose different technologies, whether it's overhead catenary lines or battery-based buses that can charge either fastly during the day or overnight in depots to make use of off-peak hours. So there are a couple of smart practices that are already deployed in different cities that are advancing this, such as London or Paris. But I do want to mention another sort of link of EV grid integration when you speak about public transport system, and that is to explore much more solutions that link the vehicle use to the use of public transport, such as metros or urban trains that are already electrified. And there's a couple of interesting projects in different European cities that try to do that, to exploit already existing grids to, for example, allow electric vehicles to park and charge, and for people to then take an electric train to commute into the city. I personally wish that these projects would be explored a bit more during cities, because I think there's a lot of underexploited synergies here.
Thank you, Julia. The next question is around the experience with smart charging, and I think smart pricing in particular. So the question is, do you have any evidence which of those practices are most popular with drivers and which gets the biggest flexibility responses, i.e., where do drivers act the most and shift load and change their charging behavior? And there's a sort of sub-question, don't drivers feel penalized when they have to pay a higher price in cases when they have to charge during peak hours and when they can't avoid having to charge their car? So Christos, I guess this is one for you. Any evidence on how drivers respond and what works well and what doesn't work so well, and what needs to be done to ensure that people actually buy into these new pricing regimes?
Thanks, Jan, and that's a great question. As a short answer, I can say that we don't have an awful lot of evidence from Europe yet. We've seen quite a bit of evidence from the US, actually. And where time of use tariffs were established, for example, and these were like communicated appropriately to consumers. We've seen off-peak charging reaching levels of 95% on average. I'm also thinking, you know, the octopus example that we showed is actually some first evidence of consumers responding to these kind of pricing signals. So I believe, you know, there is already quite some evidence that consumers, EV owners do respond to this kind of pricing signals. I mean, another point to make here is that generally what you will see, like the level of response will depend quite a bit on the design of the tariff. So for example, if you have a very short time where you apply a high peak charge, this is quite easy for consumers to avoid and shift their charging. Also, the other element that plays quite a significant role is what is the ratio between the peak and off-peak charge, or any other intermediate charge that might be in place. And I believe that there is evidence that, you know, ratios around 3:1, 4:1 tend to incentivize, tend to bring greater consumer response. I mean, in terms of the second question, which I believe was about, you know, what if a consumer has to charge during peak hours? Is it fair to be penalized? So the first thing I would say on this is that, you know, with the deployment of automated technology, this kind of risk can be very much reduced. You know, even if there is 1 or 2 days that somebody really needs urgently to charge their car at peak time, what you really need to look at is what is happening on average. And if you're doing, let's say, 5% of your charging at peak times or 2%, I reckon that overall you're going to be much better off. So I think that as a response to that question, I hope we've answered it adequately, but happy to take any follow-up questions on it.
Thanks, Christos. The next question is about EV infrastructure, and I guess this is charging infrastructure in particular. And the question is whether EV infrastructure is yet considered a public good, and whether should the cost of that infrastructure, should they be socialized, or should those costs be borne by the investors themselves?
I can take that question, Jan. It's a very good question and it merits to be asked. It's also a very difficult one. And for now, regulators, policymakers in different jurisdictions around the world have given different answers, or about to give different answers to this. In general, it remains an open question to which level charging infrastructure should be paid for by taxpayers. But there's a general agreement that some level of minimum infrastructure is required. And in Europe, this is required across all countries to actually create an integrated e-mobility market that we would want to see. And I guess that's also the spirit of the current legislative framework, the Alternative Fuels Infrastructure Directive, to allow this market to evolve. However, beyond that minimum level, it's also clear that charging services, a market for charging services needs to be set up and needs to grow in a commercial and competitive way. So consumers can choose between the best offer and the best quality of service. And that's important because we're actually currently quite far from the level of convenience, interoperability, and accessibility that we would need for e-mobility to take up. But there are some cases in which some public involvement is likely to remain to guarantee a minimum service of infrastructure. And for example, that is in rural areas where business cases for charging point operators are harder to develop due to the low density of vehicles and the low utilization rates of the charging points. But it's at the same time in these areas that more people are mostly dependent on electric vehicles because there's not so many other transport modes to choose from. And of course, rural population has the same right to go electric too. So in these cases, I can imagine that there is good argument to say that a minimum public infrastructure should be maintained.
Thank you, Julia. I now have two questions that I would like to combine. One question is about the magnitude of the benefits in terms of the flexibility, combining smart charging with variable renewables and system costs. If we did all the three things that we described in this webinar, and then comparing that to the cost of actually creating a smart charging infrastructure. So I guess the question, if we put them together, is what is the cost-benefit ratio of doing all of this? Is there any evidence that we can point to, or is this something that needs further research? So I think Christos and Julia, you can probably both comment on this question. I'll leave it up to you who wants to take it.
Okay, I'm happy to start, and Christos will probably chip in with some more thoughts here. So that question is, I guess, one of the most important to raise. So I'm happy it's been raised. There are sort of increasingly research in these sort of stacked benefits that we can gain from different levels, let's say, or different layers of EV grid integration. And if we stick to smart charging as we've described it, we can sort of come up with estimating a value of this on system level. I'm aware of one recent study conducted by Element Energy that modeled the sort of benefits of a smart charging scenario for 4 different countries: the UK, France, Spain, and Italy. And they did that for the year 2040, assuming a moderate EV uptake scenario. So one that is rather realistic, and the result is an estimated net benefit. So including all the costs associated with additional infrastructure rollout and so on, in terms of system cost savings between €500 million and 1.3 billion euros per year, depending on the country, depending on the availability of renewable resources and so on. So, by the way, I'm happy to refer you to that study in more detail. So these are first insights about how this is quantified, but of course saying that quantification requires a lot of assumptions and scenario that can vary. Would you like to add anything on that, Christos?
Yes, happy to chip in as well. So I'm not entirely sure whether the question was about flexibility to the system or what are the benefits by using the inherent flexibility of EVs per se. But in any case, I'll just add a few points. I mean, if you don't explore the inherent flexibility of EVs, what one would expect is actually that if we start charging at existing peak demand hours, and I recall a study done by Eurelectric, for example, that showed that under an uncontrolled charging paradigm, the peak demand of the system would double, basically. What this means is that you will need twice as big a power system to serve EVs, and this would obviously mean an awful lot of incremental costs. So instead of doing that, you can actually do smart charging and integrate EVs with very little or with limited additional costs. And this has also been shown by several studies around where they looked either at a larger or smaller scale, meaning a neighborhood or a line feeder. all of these reports conclude that by doing smart charging, you can really reduce the total cost for the system. And now thinking about flexibility to system operators, I mean, one of our slides actually showed how system operators could make use of this flexibility. You know, a game changer this could be vehicle to grid in the future. If you can get discharging as well from vehicles, this could be an enormous resource to the grid in terms of, you know, making sure that if there is not sufficient renewable energy generation, you can use the batteries of the cars to top up to meet your demands, and to provide all sorts of balancing services to the system operator and others. But again, we haven't quantified these benefits, but there are, I believe there are some studies out there that have. I just want to say a final thing on, you know, the benefits of this inherent flexibility of EVs, and I'm thinking about an example in California where time of use tariffs are the prevailing form, and what you're actually seeing is that the revenues that are given by EV owners are actually higher than the incremental costs they incur to the system for production, for development of the networks. What that means is that the rates for electricity consumers as a whole have dropped. So this has already provided a lot of benefit to the system as a whole. And I think I will leave it here and we can move on to the next question.
Christos, thank you. I think the next one is for you as well, to continue on. And that is a question that's a follow-up to an earlier question about the responsiveness of consumers to smart pricing regimes. And this question is about network tariffs, which you know, in our presentation we describe them as important to guide behavior. And the question is whether network tariffs are actually passed on by energy suppliers to consumers. So if we have variable network tariffs, will consumers actually see any difference in the pricing that they face, because they obviously receive their pricing signals from the energy suppliers?
So I think the answer to this question will largely depend on the member state you're in. I'm thinking, for example, you know, I live in Brussels. In Belgium, I see exactly the cost, the network cost in my contract. So what that means is that the DSO decide on the network cost, and these are passed on directly to the final consumer through the supplier. There might be cases, there might be member states where this is not the case. I have to admit that I don't have a full picture of this across Europe. But in a lot of places that I've seen, network tariffs are passed through to consumers directly. I'm afraid I don't have a lot of evidence to answer this question adequately.
Thank you, Christos. I have a question that is for Julia about charging infrastructure for electric trucks. You know, you talked a lot about electric vehicles and mainly about cars in the presentation, but is there something to be said about the smart integration of electric trucks in particular? Julia, do you have a few thoughts to offer?
Sure, thank you. So concerning electric trucks, we're obviously just at the beginning of a market development, though we have to see, we have to acknowledge that the market is developing quite quickly. So in the heavy-duty vehicle segment, I see that several zero-emission solutions, let's say, coexist at the moment, and the degree to which we will have to integrate these into the grid really depends on which solution sort of settles or reveals itself as most convenient in which use cases. So there's been a lot of debate on battery trucks, and from a transport point of view, I'd argue that these make sense in short and medium distance applications. They're obviously a great solution as electric buses in cities. I can think, for example, of electric waste collection trucks that can really help to reduce pollution, and they're obviously doing a lot of kilometers. But also in medium distance application like city logistics, delivering from a depot near a city into the center. For the long haul application, of course, the technical requirements are a bit more challenging. And here there's been a lot of talk about electric road systems, either catenary systems or electric road on the ground. And these systems are currently tested in Germany and in Sweden. There is some infrastructure that is required to roll this out, but it can obviously be interesting to run these on distances or on roads that have heavy freight use. You can think of an industrial port such as Rotterdam and the next logistics center. There are thousands and thousands of trucks that are doing short distances back and forth every day, and electrifying these with such a system would be interesting. These systems can also connect to the mid-voltage level, so there's specific sort of grid integration questions that come up with these. But on the long haul application, I actually also see a niche for hydrogen application, which after all we shouldn't forget. So there's no one straightforward answer to this question in the sense that I can recommend a specific technology. Grid integration will depend on the use case we need it for. But what is for sure is that we need to focus our attention, and government and cities need to focus their attention much more on electrifying the heavy duty segment, because freight volumes are growing and heavy duty vehicles are only a small percentage of the actual vehicles, but they're responsible for 22% of road transport CO2 emissions and growing.
Thanks, Julia. I take one final question, and that is for Christos before we conclude. Christos, this question is about network operators, and the question is whether you have any other recommendations what electricity network operators could and should be doing to help facilitate the EV integration beyond just introducing time-varying network tariffs. So is there anything else that network operators should be looking at to make this happen?
Thanks, Jan. That's a good question. I mean, one of the things that has started happening, and obviously there is a lot of potential in the future, is the active management of networks. So we are in the process, network operators, I believe across Europe, are in the process of digitalizing their networks. What this means is that they can get better information about the actual use of the networks, and what that also means is that they can offer greater capacity to the system for use of the network. This is already something that is happening a lot on the transmission level, but less so on the distribution network level, where from my experience at least, that often distributed system operators had very little knowledge about what was happening on the network itself. So I think this will be one of the key ways through which one can integrate more EVs in the system in a cost-effective way, basically making more network capacity available to the system by actively managing that capacity. And yeah, in addition to this, I think that network tariffs will be a very important part of avoiding congestions, and making sure that existing capacity is utilized to the maximum effect. And I guess just one example of this, Julia showed on a slide earlier the actual demand on one of the DSO areas in Germany. That was on slide 8, I believe, and it's based on some analysis that we did last year. I mean, what you can see is basically that there is an awful lot of underutilized network capacity, especially during the evening hours. But overall, you know, throughout over the entire year as a whole. So we've done this analysis last year, and basically this is the key conclusion. And we think that through network tariffs, one can achieve like the better use of what is already existing there, and avoid any incremental network capacity that is only being used, you know, a few hours per year, because this is not great value for consumers, basically. So I think this would be the top 2 priorities on this topic.
Thank you, Christos. This brings us now to the end of this webinar. As you leave the webinar, we would be very grateful if you could answer a very short 3-question survey. Before you leave, though, Christos and Julia, can you just briefly summarize the key messages of your presentation before we say goodbye to everyone?
Thank you. And at this stage, I want to thank everyone for a very interesting discussion and staying with us. We really appreciated having the time to discuss the great opportunities associated with integrating electric vehicles into the grid, because it advances both the clean power and transport transitions in parallel. And I think that's a key point to take away. As a reminder, policymakers on European level, national, but also local level can and should address these opportunities jointly. And we recommend to start with smart tariffs, smart technology, and smart infrastructure.
Thank you, Julia. And thanks everybody for joining us. Thanks for all your questions. Please feel free to get in touch with us if you have more questions that we could not discuss today. And you will all receive an email with the recording of this webinar. So have a good day and thank you for joining us.
Thanks to everyone.